of all, there are angles that are marked the same here. That is angle S1 and angle R. I mean, look at, here's the thing again. Look at the order of the letters they have given you. You almost know that angle P must be equal to angle P. And you also know here that somehow Q will be equal to T. You may not be able to prove it, but the order of the letters in the problem statement tell you what kind of has to happen. And lastly, angle R must be equal to angle S. And looking at the two triangles, it would be angle S1 in this case. Of course, this would have been S2. So if I look at angle P, maybe let me highlight my two triangles as well. Very, very important. I find that helpful. Angle PQR will be the big triangle PQR will be the big triangle, and then the triangle PTS will be the small one there. Okay, and it becomes clear then that the angle P is actually common in both triangles. So that's my first statement. My second statement, I see angles that are marked the same way. So angle S1, for that matter, is actually equal to angle R. This is given. It is freely given in the diagram. And my third statement, in this case, I do not really have a way to show that angle Q is equal to angle T. So this is where that statement pays off. Third angle of a triangle. Third angle of a triangle. That's where it pays off. Therefore, triangle PQR must be similar to triangle PTS. What is my reason? Angle, or equiangular triangles. Angle. Right, that's that. You happy with that?
Yes, sir.
Yes, sir.
Okay, fantastic. Let us move on. The next thing that we will do now is we will attempt to question number 2, which requires us to now calculate the unknown sides. And you're going to use similarity to do that. You're going to use similarity to do that. So I know that two triangles are similar, so let's start by extracting the ratios. PQ over PT, PQ over PT must be QR over TS, and that must be PR over PS. My reason is that I've got similar triangles. And then it is time for substitution. If I look at PQ, very, very important to note, PQ will be 5 plus 3 according to our diagram. So that's going to be 8. And say, PT is given as 4. PT is given as 4. So that's PQ, that's PT. QR is given as 10. And TS or ST is my unknown, that is the Y. PR, according to this, the very interesting one, PR is X plus 4. And then lastly, PS. PS is a 3. Putting brackets there will be quite helpful. We know the 3 equations that are going to come out of this by now. So I'll take the first equation and solve for Y. Again, it doesn't really matter. You could start by solving for X. That should be fine. Then we should do that. I will then say, therefore, 8 over 4 is equal to 10 over Y, but 8 over 4 is a 2, isn't it? So 2 is equal to 10 over Y, and then clearly then, I mean, you divide 10 by 5 to get 2, so Y has to be fine. Okay, same way we're gonna do, we're gonna work out the X value here. Again, 8 over 4 is equal to X plus 4 over 3. 2 is equal to X plus 4 over 3. you have learned how to solve equations by equations with fractions, hopefully. So we multiply by 3 flew out because 3 is the LCD, and this is 6 equals to x plus 4. The only way this can be true is if x is equal to 2. Happy? Fantastic. Then let's move on and progress to congruency. We're gonna do this again. As I said, I'll just take you through the what is congruency now? Let's do it. Oh, I'm trying to do this one. Oh no, yes. There we go. Now let's congruency. There are 4 conditions here, which you may have learned of. I'm just reminding you again. We say 2 triangles are congruent if the corresponding sides are the same. Okay. Yeah. So I hope you can see what I mean in this case. So clearly this side here corresponds with that side. Maybe I should highlight it even better and do this and say this side clearly corresponds with that side. So that's what I mean. The second condition, quite important, it's side angle side. The angle must be specifically between those 2 sides. It cannot be elsewhere, all right? So that's very important. The third one, I like referring to this one as South African Airways is side angle. As you can see, you've got a side and 2 angles. And fortunately for this one, it does not really matter where the 2 angles are, as long as you have same angles in both triangles. But of course, the correspondence is important. Maybe what I should do is I should explain what I mean by it does not really matter. And this is what I mean. You can have a situation like this, where you have an angle there, a side there, and an angle there in one triangle. And then you have that in another triangle. Again, you have that. So you see that that's what I mean. This is the side angle. Okay. Although some people like referring to it as angle side angle, it's essentially the same thing. So if you see somebody saying angle side angle, just know that they are referring to side angle. It's essentially side angle. Another one is they like switching around the SAA and they like writing AAS. Just know it's essentially the same. Okay. Lastly, number 4 is the right angle, the hypotenuse, and the one side. So this is what we are saying. You should find yourself with 2 triangles in which they are both right angles triangles, but most importantly, the hypotenuse in the one triangle must be equal to the hypotenuse in the other triangle, plus one of the sides as well. So if that's not the case, then we cannot assume that the 2 triangles are congruent. There are a number of questions being asked around this, from proving that stuff is congruent to using congruency to prove that angles are equal or sides are equal. There's a lot of work here being done. So I want to do 2 examples with you again. Unfortunately, I will not go through all the 4 conditions or 4 cases of in terms of examples, but one thing that I will definitely do here, and I'll do justice to, is to show you how you could prove that 2 triangles are congruent, and then after that I will then show you as well how to use congruency to draw some conclusions. So let us start with the case where you have to prove that 2 triangles are congruent. So this is my sketch here. Put it up nice for you here to see. Butterfly. We've got a butterfly here. And then look at the markings now. This here is marked the same way as that. And this is marked the same way as that. You are told this is point O, that's O1, O2. This is point A, that is point B, that is point E, and that is point D. Very, very important. Let me see here. You are required to prove that the two triangles are congruent. And in fact, no, you are not required to prove that the two triangles are congruent. This is what you are required to do. You are required to prove the following, that the side AB is equal to the side ED. Okay, so I'm going to kill two birds with one stone here. What I will do first is I will show you how to prove congruency, and then I'll show you how we use congruency to conclude that sides or angles are equal. Now, three things. Remember, all those three conditions of congruency have three things in them. Either three sides, or side angle and a side, or side angle, or RHS. Okay, so in this case, I need to see I've got two obvious things here. The first obvious thing is that AO is equal to DO. That is freely given. The second obvious thing here is that BO is equal to EO, also freely given. But the non-obvious, which requires our prior knowledge of angles, is the fact that angle O1 is equal to angle O2, and these are vertically opposite angles. So I need to see how the previous geometry comes in. Therefore, now let's check. I've got a side, I've got an angle, and I've got a side. So therefore, triangle. Remember now, if I didn't say it, I'll say it now, that as in similarity, the order of letters is also important in congruency. How we name our triangles is quite important. We have to be very conscious there when we do that. So I'm going to go AOB. Now, since I have gone triangle AOB, by the way, this will be the sign for congruency. Okay, you just take those triple I's from similarity and rotate them. Now, which triangle? So I need to be careful. I went from A to O. So what should I do with the second triangle? I must go from what to what? I must go from D to O. So this will be triangle DO, and obviously the third letter is quite obvious. It will be what? E. So I must go to triangle DOE, Department of Education. All right. Then the power of congruency comes here now. Yes. Yeah. This is now where the power of congruency comes. Once you have, oh, by the way, we have to justify. Sorry, side angle, side. You have to justify. Now, this is where the power of congruency comes in. Now that you have shown that the two triangles are congruent, you can conclude that the following is true. You can conclude that AO is equal to DO, which is quite obvious. We know this one from our proof. We also know from our proof that BO is equal to OE. We're good. But what we did not know from our proof, and we can now conclude, is the fact that AB is DE. And guess what? It does not end there. You can do the same thing with the angles. I can conclude that angle A is equal to angle D in that triangle. We already know about O1 being equal to O2. We can also conclude that angle B must be the same as angle E. That is the power of congruency. So just like that, we are done. We will then come to our proof and say, well, clearly AB must be equal to what? DE1, because I've proven that the triangles are congruent. Or you can say triangle AOB is congruent to triangle DOE. Take note that you will be marked wrong if you draw this conclusion and the letters do not correspond. in your statement, in your conclusion. So you actually draw this conclusion based on the order of letters there, and of course, having proved correctly. Okay, is that good?
Yes, sir.
All right.
Yes, sir.
And I show you it's the same thing for all other conditions of congruency. So if you can just be quick, familiarize yourself with these conditions of congruency, all should be well with everything. Okay, all good.
Yes, sir.
Right. We're gonna close it here then for the day. Yeah, well, and then good luck, all the best for you.